This is not a movie. We are watching the world's first competitive fighting tournament for humanoid robots. The fallen robot's joints whir. It tries to push itself up. This single moment, this desperate struggle against gravity, is more than just a sport. And how did we get to a point where science fiction concepts from films like Real Steel are being broadcast live on state-run television? Okay, to understand what you just saw, we need to back up. Robots themselves came from private firms like Unitree Robotics. This public-private partnership is the secret sauce, designed to solve the financial problems that reportedly killed past ventures like King of Bots.
We're going to robots versus wrestlers!
Chapter 1. Anatomy of a Fighter. So, what about the machines themselves? The exclusive star of the show was the Unitree G1, a child-size humanoid standing about 1.3 meters tall and weighing 35 kilograms. This smaller size was a strategic choice for a debut event, prioritizing safety and manageability. Now, if you're picturing the towering heavyweight machines from the movie Real Steel, think again. The G1 is more like the film's unassuming underdog hero, Adam, pint-sized, agile, and engineered with a surprising level of sophistication that was completely underestimated. But don't let that size fool you. Its design is incredibly sophisticated. One of its most impressive features is the ability to fold itself into a compact block, hinting at its potential for deployment in all kinds of space-constrained environments. Its agility comes from its modular joints. The base model has 23 degrees of freedom, but the advanced versions used in the tournament can have up to 43. These joints are powered by high-speed motors that can deliver up to 120 Newton-meters of torque at the knee. That immense torque is precisely what's needed to execute a dynamic, forceful kick, and critically, to recover from a fall. To see its world, the G1 uses a combination of 3D LiDAR for a 360-degree map and a depth camera for rich visual data. But its brain is where the strategy lies. The standard G1 has a powerful 8-core CPU. The tournament models, however, are equipped with an optional NVIDIA Jetson Orin module. This single add-on transforms the robot. It provides up to 100 TOPS. That's 100 trillion operations per second of AI processing power. This is what allows the robot to run the complex, real-time AI models needed for perception, planning, and decision-making in the heat of battle. And how does it learn to fight? The movements aren't just simple animations. Engineers worked with professional fighters, using motion capture to record the data from real jabs, hooks, and kicks. This data becomes the training set for the robot's AI-backed control system, allowing it to develop fluid, human-like movements. The fight itself is the final exam, an extreme stress test to refine its stability under pressure. Chapter 2. The Rules of Engagement. Now that we know the hardware, we can understand the genius of the rules. The competition wasn't just about destruction, it was engineered to solve specific robotics challenges. Each match was 3 two-minute rounds. Scoring was simple but revealing. A punch to the head or torso, 1 point. A kick to the head or torso, 3 points. Why the difference? Executing a kick requires a vastly more complex level of dynamic balancing and multi-limb coordination. By heavily rewarding kicks, the rules forced teams to master the hardest parts of humanoid locomotion. Penalties were all about stability. Fall down, -5 points. Can't get back up within an 8-second count, that's a -10 points. And the round instantly ends. It's a technical knockout. This rule puts immense pressure on creating robust failure recovery routines, a vital skill for any real-world robot. But this leads to the most important revelation of the tournament. The robots were not fighting on their own. This was a human-machine collaborative model. Ringside operators used handheld controllers, but they weren't micromanaging every motor. It's a concept straight out of the movie Real Steel, where the human operator is the fighter's mind, and the robot is the body. The human's role was purely tactical. They issued high-level commands like throw a hook or dodge left. The how was up to the machine. It had to calculate the limb trajectory, adjust its center of gravity, coordinate dozens of motors, and process sensor feedback, all in real time, just to execute that single command without falling over. This was a brilliant choice. It allowed developers to focus on perfecting the physical challenges, balance, coordination, force control, without having to solve the much harder problem of fully autonomous combat strategy. The fights were, in effect, public gamified stress tests for the robot's physical intelligence. Chapter 3: The Human Element. To make the story compelling, the 4 participating teams were branded with unique personas. You had the pink team, the Silk Artisan, focused on lightning-fast attacks. The green team, Power Core Guardian, who used a methodical, engineering-driven advance. Creatively, the red team, Armored Mulan, who brought creative, unconventional moves inspired by cultural heritage. With cold precision, and then there was the black team, AI Tactician, operated by tech influencer Lu Xin. Their style was defined by flawless calculation, impenetrable defense, and subtle, decisive moves. After a series of intense bouts, it was the black team that claimed the title of Iron Fist King. The victory was attributed not just to the robot, but to the operator's superior tactical execution and the robot's resulting endurance. The celebration was pure spectacle. The victory of the tactician proves that winning isn't about raw speed. It's about a symbiotic understanding between the operator and the machine, knowing the robot's limits, managing its energy, and striking at the optimal moment. This tournament was effectively a training academy for the pilots of the next generation of robotics, honing skills directly transferable to remote surgery, disaster response, and space operation. Chapter 4: The Real Fight. And that brings us to the geopolitical arena. The global media immediately framed this tournament as a proxy battle, China's Unitree versus America's Boston Dynamics. While Boston Dynamics Atlas is a technological marvel, it's a lab-bound legend, largely inaccessible. Unitree is playing a different game. They are not trying to build a better Atlas, they are building the robotics equivalent of the IBM PC or the Android operating system. With a base price of around $16,000, the G1 is an affordable, commercially available platform. The fighting tournament is brilliant marketing to get this platform into the hands of a global community of developers, researchers, and educators. They are competing not on peak performance, but on accessibility, market share, and the power of a developer community. It's a classic disruption strategy. Capture the broad base of the market with a good enough product that's improving exponentially. Chapter 5: The Endgame. Which brings us back to that fallen robot in the ring. What we were watching wasn't just a fight. It was Phase 1 of a public roadmap. Phase 1, Master the Body. By putting a human in the loop, they perfected the physical machine. Balance, coordination, recovery. But the real bombshell was the announcement for the next tournament. December 2025, in Shenzhen. The robots will be full-sized, and, most importantly, they will fight autonomously. This raises the ultimate dying question. Are we witnessing the birth of a real-life real steel, destined for giant arenas and massive heavyweight machines? The roadmap is clear. Phase 2, Master the Mind. They are removing the human training wheels. The challenge shifts to the Holy Grail, enabling a machine to make its own tactical decisions in a dynamic adversarial environment. It's about building a true autonomous agent, and this is the true endgame.
That's the endgame.
The ultimate goal isn't a sport. It's using the crucible of combat to forge autonomous physical agents, a robot that can autonomously fight, perceiving, deciding, and acting under pressure, has mastered the core loop required for almost any unstructured real-world task. Think of the practical applications: an autonomous police unit that can enter a hazardous standoff, or a military robot that can patrol dangerous territory without risking human lives. The same AI that can dodge a hook can navigate a disaster zone. A successful autonomous fighting robot is, by definition, a highly capable general-purpose robot. And in the global race to build the next frontier of technology, this tournament reveals China's path to get there first. The fight in the ring is just the most spectacular and public first step.